All right, so up on the board, get some of this out of the way. Okay, we are dealing with composite figures today. Okay, and that's just simply figures made up of triangles, squares, rectangles, semicircles, circles, two-dimensional figures. Okay, they're flat, they're not 3D, which is good at the moment. Okay, so they gave you a couple examples here just so that you can see the visual here, right? There's your square, there's a triangle, which we'll talk more about here in a minute. Okay, over here we got a rectangle and a semicircle. Okay, now these are easy, but you have to pay attention to the markings and what you're trying to find. Okay, because once again, I'll show you where we go make our boo-boos. Okay, you are allowed, if you read the daily agenda today, you are allowed to use the cheat sheet. That is correct. You don't have to memorize any formulas. Okay, so if you need, it's in the class resources. Okay, there's two cheat sheets in there. You pick the first one. Okay, and you may use that if you need it. Okay, but here's why I have this screen up. Here's what I want to talk about here briefly, and then I'll get to a blank screen. Okay, so you're going to run across some objects that are on grids. Okay, you might want to pay attention because this is going to be on your quiz and your test. Okay, so you see that arrow in there, yes? Okay, now this is right out of your book page. That's the easiest thing to do. Okay, so if you see where that arrow is pointing to, it's pointing to the diagonal line, yes? Okay, that arrow or that line, the diagonal, is opposite the right triangle. Does that make sense? See if I can do something here. Right, here's our right triangle. Yes? Okay, the arrow is pointing to this. Do you know what this line is? Do you know what it's called? This is a right angle. Okay, they're saying that this is 1.5. If that's 1.5, that means this has to be 1 or that has to be 1. It's the longest side on a right triangle. Now, this isn't part of the lesson, but it's a good place to interject this. Anybody know what it's called? It's called the hypotenuse. Okay, you don't need to know that right now. Just know that if you ever hear that word hypotenuse, it's the side opposite of a right angle, and it is the longest side. Okay, listen, there's a way that we can figure this out. Okay, it's called Pythagorean theorem, and if we get there in the end of April and May, that will be fantastic. But right now, you don't have to learn how to calculate it. Okay, there is a way how to calculate it. So the easy part for us right now is everybody will be using that length as 1.5 times. Does that make sense? Everybody good with that? Everybody good? Okay, because the grids here, right, these squares, they're just saying they're 1 inch by 1 inch. Okay, everybody good with that? Okay. Then we are going to move on. All right. Oops. So again, lesson 6.2. Now look at what we're dealing with. Perimeters. perimeters of composite figures. So we're just finding the distances around objects. Okay, next week, right after the quiz on Tuesday, then we're going to start dealing with finding the area of objects. It's a little bit more interesting. Okay, but right now we're just dealing with perimeters. That's why you found circumference and you already know how to find perimeter from elementary school. All right, first object. Looks like this. Okay. And here's what they'll ask you to do. Pretty simple stuff, right? Okay, question number 1. Oh, wait a minute. Sorry, let me put more markings on there. Okay, question number 1. Why the dotted line? Michael? Okay. Okay, good answer. Emma, what were you going to say? Okay, yeah, okay, right? We got two different shapes there, right? So it appears, now this is the funny part, okay? What you can't do, and this is not in the book, so you might want to open your ears. Sometimes the shapes appear by the naked eye when you look at them to look like something other than they're not. What? What do you mean, Mr. Fisher? Well, sometimes rectangles will look like squares and squares will look like rectangles, is what I'm getting at. How am I going to know the difference? Well, you have to look at the markings. Okay. Now, they give you in this example, in the example that we have, right? The base here is 5 and the vertical on the right is 5. Well, what does that tell us about the measurement from here to here have to be? Go ahead. It's got to be 5 meters, right? It's got to be the same. Okay. I wish you could see it in the book. Okay. You can't, but it looks like a rectangle, but it's really a square. Okay. All right. So if that is being said, right? So we found, let's be honest, we found the perimeter. Let me get my colors going here. We found the perimeter from here to here to here, right? That's 15, right? That's pretty easy stuff. Okay, so now we have to find our semicircle, correct? Okay, so what was our formula for a semicircle? You can look at it from yesterday, that's fine. Okay, what do you got? Whoa, don't give me numbers. Just give me like what it is. Very good, sir. Divided by 2. Because 3.14 times D is what? Very good. The circumference of a whole circle. Okay. Again, I'm going to point these things out because Tuesday's going to be here before you know it. This is going to be a common mistake. Okay. All right. Very good. So we're going to take 3.14. Uh-oh. What's my diameter here? And how do I know? Brady, how do you know? That is correct, sir. Very good. That is something that you should have learned in elementary school, right? Opposite sides on a square or opposite sides on a rectangle are the same length. Very good. Notice they didn't give that to you, right? Again, they're expecting you to carry things over. All right, so I'll do the math for you. 3.14 times 5 is 15 and 7/10 divided by 2. Some of you are going to make that boo-boo. Is equal to 7 and 85 hundredths. Okay, 7 and 85 hundredths represents the semicircle, the curved portion of the semicircle. So what do I do to 7 and 85 hundredths? Cole? No. Ooh, I'm glad you said that, though. I didn't think anybody was going to do that. Okay, so Cole said, no, this is good, Cole. I appreciate it, buddy. Add it on to the diameter. Do we want to do that? Is that dotted line, is that the perimeter of the object? No. No, so let me make hopefully this analogy kind of makes sense. Remember we talked about walking the perimeter of your yard? Okay, that would be like you starting to walk the perimeter of a yard and then all of a sudden you cut through the house. Well, but that's what it's like, right? You don't count that portion, right? Good job. Hey, Cole, thank you, sir. That was awesome. We're not gonna add the 5, but to Cole's point, he's right. Guess what? Some of you are going to add that back in. This is not the perimeter. We want to start at one point and walk around all the way around the house. So what am I going to add it to? Grayson? That would be 15. That is correct. And now we're going to get a whopping 22 and 85 hundredths meters. I know there's a lot on that board, but I think if you were following along, you know what all that means. Okay, so with that being said, take a look at that screen. We were just to find the perimeter and look at all the math we had to do. It can get confusing. Okay, and I'll be honest with you, that's a pretty simple object. Okay, everybody good with that? Any questions? Okay, moving on. Second object. Okay, there's our markings. We'll put feet on these. How's that? All right, we want to know, again, let's find the perimeter. What can you first tell me by just looking at that object, just pure observation? Emma? Yeah, we're missing a few things. Like what's the distance down here and what's the distance over there? Kind of important, right? All right, how do we find them? Michael, which one do you want to find? Okay, how do we find that? Okay, very good, sir, right? So if you notice this, up top is 14, right, in the blue. And if we were to bring that down here, right, that would go from there to there. And then Michael recognized, hey, over here, I got the rest of it is 5.5, and this is 14. All right, and when I add them together, that's going to give me my 19.5 for that distance. Very good. How do I find this? Emma? Nice job. So 12.5. Now I got to subtract because the distance, let me change colors here. The distance from here to here is 12.5, and that goes all the way up there, but there's nothing there. I have to subtract that 4 out. And when I subtract that out, I get my 8.5 feet. Very good. Okay, this is a little bit of an easier one. And now all I have to do is add them up. That's correct. 14, 12.5, 19.5, 8.5, 5.5, and 4. Anybody adding those? Or do it? I'll do it. $64? 64 feet. Now, important. I know on the quizzes and tests we're not, too keen or, too not up to on the labels, but make sure you put them on your paper. 64 feet. Because next week we're going to start using that little 2 above the labels, which means something totally different. Remember the dimensions that we went over? 1 dimension, 2 dimension, 3 dimension, right? This is a 1-dimensional answer. 64 feet. You're finding the distance around an object. Logan, you have a question?
I noticed that you could still solve this even if one of the red values are missing.
Correct. That is correct. All right, next object. Just a little bit harder. Oh boy. Okay, so we have a right angle. We have the height is 8 feet. The base is 6 feet. And the hypotenuse is 10 feet. Now, if you would ever see a triangle, which at the moment you're not going to, but I just want to share this with you. Okay, a little side note here. If you ever see something, and we'll just use the same measurements, 8, 6, and all of a sudden this is like, I don't know, 9. Okay, well, no, let's change that. Let's just use it as 8. We'll say 8. Okay. Can that can that happen? Can that triangle happen on the right based on what I've said this morning? The answer is no. Okay, that means that bottom piece doesn't close. Okay, now we haven't talked about open figures yet, and I don't think we'll ever get to it because that's not part of our curriculum, what we need to get to. But the hypotenuse opposite the right triangle has to be the longest side of the triangle. It has to be. Otherwise, it's an open triangle. Everybody good with that? Okay. I just want to make sure that we're clear on that. Okay. Just so I'm showing you that and telling you that so you could look at the markings and understand and make sure that they are correct, right? All right. So here we go. Again, we're going to we're working on the perimeter. Okay, well, let's be honest. I think it's pretty easy to go from there to there, right? That's 8 plus 6. That's going to give us 14 feet, correct? Okay, that's the easy part. All right, so now we got to find, here we go again. We got to find one of these. So to Kahan's point, that's 3.14 times the diameter divided by 2. So again, plug in 3.14. The diameter here is 10, right? Divided by 2. So that's 31 and 4/10 divided by 2 is going to give us 15 and 7/10. That's the distance around the circular object. Cole, are we going to add back in that 10? Are we going to add back in this 10 right there that I just underlined? No. What'd you say? Correct. Very good. We're going to add it to the 14. That is correct. 29 and 7/10 feet. Very good. Very good. Very good. All right. Everybody good? Last one. We'll do one more. Then we'll let you get to business. Okay. So we got this. And we'll use centimeters here. Okay, again, nothing's changing. We're going to find the perimeter. So what shapes? Just yell out the shapes that we got. Got a rectangle and a triangle. Okay. What's the distance from here to here? 7 centimeters. Do we need to know this? Do we need to know the height of the triangle? Is that the perimeter? Okay, correct. It is not. It's in the inside of the figure, right? So we don't need it yet. Next week, when we talk about area, we're going to need to know that measurement. Okay. What's the 5 called here? Very good. There you go. Some of us are getting it. The hypotenuse. Okay, so here we go. Start one place. We got to go around. So 4 plus 7, 11 plus 5, 16 plus 3, 19 plus 7, 26 centimeters. See how easy that is? All right. All right, we'll let you get started then. What do we got today? Okay, we're lesson 6-2. There is. Yep. 1 through 17. Shh, I'll send it to you. Don't worry. 1 through 17, the odds. That's correct. 3. What did I say? Oh, I'm sorry. And an Ed puzzle. Now, somebody asked earlier, it was a great question. They said, hey, Mr. Fisher, are those Ed puzzles product or process? At the moment, they are process. Well, they will turn into product once well, I'm going to give you some time to get used to them. Okay, and then they're going to turn into products. Okay, if there's no questions, you may get started.